Okay, guys, what we're going to look at today is your seasonal analysis. Now, when we talk about seasonal analysis, what we are saying is that there is seasonality in the time series, and we want to find out what that seasonality is so that we can make accurate decisions moving forward into the future. As I said in other videos, you've got seasonality on something like heaters. You will sell more in the winter than you will in the summer. Beachwear, you'll sell more in the summer than you do in the winter, and so on. So all products have got seasonality in their sales volumes. Why? Because there is consumer seasonality. People buy more at the end of the year because they usually earn a bonus and they buy gifts for Christmas and all of those things. So there's cultural and economic factors that cause seasonality. If you look at the travel industry, some things like public holidays and general holidays, religious holidays, cause seasonality in the travel industry. So all industries have got inherent seasonality where you will sell more in certain months than you would in others. So we want to know when these months are so that we've got enough resources, enough stock, enough staff to service our clients, because if we don't have enough, we will lose out on sales. So we want to make sure that if there is an increase in sales or business, we can cater for it, and we also want to make sure if there's a downturn in sales that we can also cater for that in terms of cash flow and all of that. All right. So that's why we find seasonality so interesting. When we look at your seasonal analysis, they've broken it up into a few very easy steps. And when I say easy, it can be very confusing. So I'm going to go through the steps, and then I'm going to go through the example in the textbook, and then after this video I'll do another video just quickly on a actual example. So the first step is you have to calculate your term. Now, for all practical reasons, we are going to say that a term, or your K value, is the number of observations you've got in a year. So if we look at our data on a weekly cycle, you've got 52 weeks in a year, therefore your K value would be 52. If you look at it on a monthly cycle, you've got 12 months in a year, therefore your K value would be 12. On a quarterly, you've got 4 quarters in a year, so K value would be 4. Semi-annually is twice a year, so your K value would be 2. So we need to look at how often do we observe our data. Usually, specifically with sales, it is monthly. So again, 12 months in a year, so your K value would then therefore be 12. So the first thing is to understand how many observations have you got in a cycle. 99% of the times our cycle is 1 year. So we're going to look at a K value, and we need to, from the question, identify what our K value is. Number of observations per cycle. All right, guys, once we've got that, we want to calculate our seasonal ratio. Now, guys, you have to pay attention to your seasonal ratio, and as I will go on here, you'll see we start talking about a seasonal index and then a adjusted seasonal index. So just keep your bearings together when we talk about a seasonal ratio, seasonal index, and an adjusted seasonal index, because that's where a lot of you do get confused. So first step is we want to find the seasonal ratio. I'm going to call it SR just to save some real estate on my page. So what our seasonal ratio is once we've calculated a trend line, we want to see what the difference is from an actual value to the smoothed out trend line. So there we can see that there's a continuous trend upwards, but on period, let's say 1, 2, 3, 4, 5, on period 5 we see a massive downturn, and on period 6 we see a upturn again. So now we can say we've got 6 periods here. So if our K value is 6, it would be every second month. So we can say that on every second month on period 5, you will see a drastic downturn in sales. So that is your SR value. It's basically a percentage, because you can see it's your actual Y, which is there, divided by your moving average y, which is that point, which is the point on the trend line. So you divide your actual y over your moving average y, and for example, let's say this actual y is 50 and that moving average y is 60. Your SR value would be 50 over 60 times 100, and that would give you a value of 50 divided by 60 of 83%. So that would give you an 83% SR value. So you will just do 83% of your normal sales. So instead of doing 100% or 110% of your normal anticipated sales, you'll only be doing 83% of your anticipated sales, or of your moving average. So that's all in fair. That's an easy calculation. We get our seasonal ratio and we can calculate that. Now, this is where things start getting a tad bit more complicated. So now what they are asking us is they want to get a median seasonal index. And roughly summarized is they want you to average the seasonal ratio per period. So average the seasonal ratio per period. So what you will have is you will have a table that will look something like this, as all tables do, and you will have probably Q1, Q2, Q3, Q4 in 2017, and then Q1, Q2, Q3, Q4 in 2018, and Q1, Q2, Q3, Q4 in 2019. So what you will have is you'll have a moving average for these values. You'll have your SR, which is your actual divided by your moving average. And now what you want to do is you want to, for each period, so this, what they're referring to is you want to calculate the value or the average of all the Q1s together, and then the average of all the Q2s together. So we're taking a specific period in each year, adding them over the amount of years that we're working with, and we get the average of that. So if you can see, for example, in this table, you will see that the original table looks like this. You've got your Y, you calculate your moving average, which we have gone through, calculate your seasonal ratio, which is your Y over your moving average, and then what they do is they transpose the table to have your periods in the columns and your years in the rows. And then basically all they do is they get the average. Now in the textbook they say get the average, but in the definition you can see it's the median that they are talking of. And if you can remember in your previous course, the median is the number exactly in the middle of the data set. So the number in the middle of this data set is 79 because it is in between 75 and 81. In this one it's 85.33 and so on. So we pick the number in the middle of the data set, and that will give us our median seasonal index. Okay, now I hope that all of you are still with me. What we're going to do is we need to normalize this value. Now the reason why we need to normalize it a bit is because we've taken the median, and that can throw off the mathematics a bit. So as you can see, what we've got is we've got 4 quarters, and they add up to a value very close to 400. Now this is your K value here is 4, because you've got 1, 2, 3, 4 quarters or 4 observations in a year. So your K value is 4. And this number surprisingly comes very close to 4. But we want to get it exactly to 400, or theoretically stated, we want to get it exactly to k times 100, which is 4 times 100 is 400. So therefore, what we need to do is we need to do an adjustment factor, and the calculation for your adjustment factor is k times 100, which is your 400 in this instance, over the sum of the median seasonal indexes. So guys, that's very straightforward. For this, we've got the sum of all the median instances is 402.43. So we've got 400 divided by 402.23, and that would give us a number of 0.994, and that is the same value they use here. And what that adjustment value is it tells us that if you multiply your median seasonal index with that number, you add them up again, you will get exactly 400. So this is now the fourth and final step, is you will get an adjusted seasonal index by calculating your adjustment factor, multiplying your median seasonal index with that, and getting a new adjusted value, which adds up nicely to 400. Now, guys, what do we do with this final adjusted seasonal index? What we do with that is when we start looking at making a forecast. How do we make a forecast? So when we do a forecast, we need to do a few things. We've got some data points, and on these data points, we calculate a trend line. Now, we want to see what is going to happen in the future. In order to know what's going to happen in the future, we need to continue with this trend line, which is easy because we get this as a formula, which is our regression analysis, which is your y equals mx plus c, or your b0x plus b1, which we've done in the calculations, and you can then therefore, if that is period 11 and you want to look at period 12, you replace x with 12 and you get a new y value. But that is just your trend line value. You then need to take that value and multiply it with your adjusted seasonal index, because that might be one of your down months where you only sell, for example, 83% of your normal sales. So you can get the future value by replacing the new period value into your regression, and then you calculate your seasonal index or adjusted seasonal index, and you multiply that value with it to get your actual value, which you can then start forecasting values into the future. I will do an example of this. This is the full example. Why is this the full example of time series? Because what you need to do is you need to get your regression, number one. Number two is you need to get your moving averages so that you can calculate your seasonal ratio. Your seasonal ratio will give you a seasonal index, and you will put that into an adjusted seasonal index. And then your regression will give you an equation of y equals b0x plus b1, and then you can take a future value, plug that into your x value, and take your y value and multiply that with your adjusted seasonal index.